Okay, C4 Chapter 2, integration by parts. You've done more differentiation so far than you have integration. What were some of the last things you learnt about in differentiation? Any rules to help you in any way? There are two rules in particular I'm thinking of. One rule, something, a P word and a Q word. Quotient rule and product rule, yeah. Integration by parts, it's sort of the integration counterpart of that really. We use this is used to integrate products. Okay, so we need to know when we're using it. We use it to integrate products. Now, first time you see the formula, it will be sort of meaningless to you. Copy it down, stick it in the red box, highlight it, then we'll do some examples. So if we integrate U dv dx with respect to x, we get uv minus the integral of v du dx dx. That is the rule for integration by parts, the rule, the formula. Please use good colour in your notes to highlight these key things. I will keep going on about my Redbox rules. This is sort of one of them. There is another way of writing it down as well, which is this. Okay? Can anybody explain why those are the same and why that's a sort of shorthand version and what's going on there? What's the significance of these little dashes here?
Dash means it's been differentiated.
Yeah, dash means it's been differentiated, yes, that's right. So V has been differentiated, so that V dash is the same thing as that dv dx. That U dash is the same thing as that du dx. Okay, so that's a shorthand way of writing down the same thing. You'll probably stick with the top one most of the time. So if we just get stuck in straight away by doing an example. Right, first question I guess is, do you agree that that's a product? And if it is a product, what are the two bits? So, Jack, what are the two bits that are being multiplied together here?
X and the cos x.
Yeah, okay. The x is one bit, and the cos x is another bit, okay? And I find actually often quite useful just to put these sort of liney, brackety things there, just so you know what the two bits are. Right, now, the process you've got to go through is this. You've got to decide one of these bits of the product. One of these bits is going to be my u bit, and one of the bits is going to be my dv dx bit. And you've got to now choose which is going to be which. So what you've got to do now is you choose which part will be u, choose which part of the product will be u. What will you do to u? Over here you've got u written down. What happens to u over here on the right hand side? Gone? Yeah, you differentiate it. So you choose it, and what happens is you will differentiate it. You will differentiate it. And you're trying to choose it so that once you've differentiated it, it makes things easier. It gets easier. So you choose one bit to be u. The other thing we've got to choose is what bit's going to be dv dx. Well, it's obviously got to be the other one. So you've got to choose which part is dv dx. What happens to dv dx? Over here it becomes a v, so you have integrated. So that one, you will integrate it. So when you choose it, you've got to be able to integrate it. If you can't integrate it, then it's a bad choice for dv dx. So if we look at this line up here, I'm just going to write it down again because otherwise I'm going to sort of run out of space on the screen. That's what we've got so far, that bit and that bit. Which can you integrate, or let's start off with this bit. Can you differentiate either of them, both of them? You can differentiate both of them. Can you integrate them, either of them or both of them? Can you integrate x? Yes, you should be able to integrate x, okay? You can integrate them both, but you can differentiate them both. Which becomes much simpler when you differentiate it? X, because it becomes... Yeah. So, that's how you come to the conclusion about which way round you do it. If you differentiate x, it becomes 1. And that's just as simple as you can pretty much get. So that bit there, if I want to differentiate it, that bit will be my u. And it's my u because when I differentiate it, it becomes just 1. Because when I differentiate it, I get just 1, and that is pretty much as easy as it can get. So that's why you're going to set that bit to be u, which means this bit here has to be the dv dx bit. And you can integrate it, so that's okay. You can integrate it, so that's okay. If you couldn't integrate it, well, it wouldn't work this way. So, are we all happy so far? Right. Just to keep things together again, I'm going to rewrite that one more time, just so I can line it up with my Redbox rule. So, there's my Redbox rule. There is my question. Here's me splitting it up. Okay? So what I would do now, if I was doing this in an A-level question, I would write down somewhere, so u equals x. Then on the right-hand side of my page, I'll write down dv dx. I've chosen to be my cos x bit. So this is my working out bit. Now, what have I already said? What do I need to do from my u bit? I need to differentiate it to get... The answer will be 1. Yeah, what will I write on the left-hand side of the equal sign? Yeah, go on. You're all saying it, I think, pretty much. du dx. Yeah, that's right. Okay, and then over here, what do I need to do with this bit? Integrate it. So what will I write on the left-hand side of the equal sign? v. Okay, and what is the integral of cos x? It is sin x. In a minute we'll just go back and check that you know all the integrals and differentials things you need, because I noticed last year in the notes I did, I got a whole page of things, but I think the class probably had forgotten. So we'll go and just check over those in a minute. So I've got my question, my Redbox rule, my 4 bits, and now all I do is go to my right hand side up here and I substitute all the bits in. Now I tend to use I for the integral, just to save writing out the left hand side again. So I am going to do now u times by v from my Redbox rule. So u is x, v is sin x. So that has come from, that bit was my u, that bit there was my v, and I'm taking this now from the right hand side up here. And then I need minus the integral of v, that's sin x, times by du dx, that's 1, and I'll write my dx down there. So that is my v, and that is my du dx. So all I've done there is just substitute it in. Are we all happy with that? So I've got over here x sin x, I'll leave that as it is. Over here I'm integrating sin x times by 1. In other words, I'm just integrating sin x. What is the integral of sin x? integral of sine x. I think you're saying the right thing, Jim.
Minus sine x.
Oh, no, you got the first bit right. It is minus.
Cos x.
Minus cos x, yeah. So the integral of sine x is minus cos x. So that's everything to the right of my fingers then. I need to write this bit in over here as well. X sine x minus. Okay. So basically everything to the right of that dashed line is the same. Because I've now finished, there are no more integral signs anywhere. At this point I write in my plus c on the end because I have no more integration to do. And how would you write that answer down a bit more nicely using a bit less ink? What change can you make in the middle? Yeah, those two minuses make a plus. So you get x sine x plus cos x plus c. And that is the answer to that question. Okay? That is how it works. I'm going to stop the videoing there for a minute. This is not new stuff here, this is just checking stuff you should know which you will need to know for this chapter. If y is sine x, what is dy dx? Sorry? Not minus cos x, just cos x. Okay? So these you need to learn, and if you want to write them down now all in one place on a page, then do that. It might be a useful thing to do. You need to just have these at your fingertips all the time, okay? Differentiate sine, you get cos. Right, what's the next one I've got here? Differentiate cos. What do you get? No, it's not cosec. Not cosec. Not tan. Not minus cos.
The other one.
The other one, yes, it's the other one. It's minus sine. Okay? So, you really do need to learn these and have these at your fingertips because you're going to be using these over and over again as you go through. Right, I'm not sure what's coming next, but let's see if we have any better luck. What's the integral of sine x? Haven't we done that one already today? Minus cos x is correct with a plus c on there. Yeah, okay. Next one. Integral of cos x. Remember, integration is just the reverse of differentiation. So if you've got an integral of cos x over here, and you've got a cos x over here, the answer to it must be... Yeah. Okay, sine x. Right, okay. Basically the same stuff, but now with basically a number in front of the x. So if you have y is sine mx, where m might be like a number like 4x or something, what will dy dx be? Want to say it a bit louder?
M cos x.
Very close. M cos mx. So the m stays in front of the x and also comes out to the front, and we're just basically using the rule we had here. Sine differentiates to cos, but the m stays there and also comes out here. So the next one, what does cos mx differentiate to be? Follow the same pattern you had up here and follow the same pattern here and you'll probably get it right. What does cos mx differentiate to?
Minus m sine mx.
Is correct. Well done. So, cos differentiates to minus sine and the m goes in front of the word and stays there. Right, what's coming next? Oh, integrating these, okay. So what's the integral of sine mx? We're now integrating, so we will not have a timesing m in here. That's my clue to you. If the m wasn't there, what did we have earlier on? What's the integral of sine? Okay, so it's going to have that sort of thing in it, but we're not going to be timesing by an m. We're not differentiating. What do you think we might be doing? What often happens when you integrate? You don't times, but you divide. So, what do you think we might get here, integrating sine mx? Bit louder.
Minus cos x over m plus 3.
Apart from that m in there, which I'm not sure you said. Yes. Okay. So the m stays in front of the x, the multiplier stays there, and we divide by that one. You can probably guess what question's coming next. I did this logically. What's the next question going to be? Integral of cos mx. Yeah. Okay. Put together what you've seen so far. What will this one be?
Sine mx over m.
Sin mx over m. Spot on. Yeah. There we go. So those need to be at your fingertips. Okay.
What about tan?
You need to know some of the other ones as well. Okay. They're in the some of them are in the formula book. Just that, if you just get that list at the moment, those are the most common ones you really need to know. Okay. Right, so if we start another example, if we start example number 2, and we'll do that in a different video clip. Okay, so here's our second example of integration by parts. What two bits make up the product? Ella, what are the two bits in my product here?
X and equals 3x.
Okay, that's right. Now what I need to do now, I need to choose which are going to be my two bits. And if we go back to the Redbox Rule, which is here at the bottom, I need to choose one of the bits to be a U, so I will differentiate it and hopefully it gets nicer. One bit to be my dvdx, which I will integrate and I can do. So what will you choose your U to be here? Got to be one of these two bits here. X. Yeah. Okay. Then I've got to choose my dvdx. Well, that's got to be the other bit, so that's got to be my cos 3x. Okay. I'll just write the Redbox rule down again so we can see what's going on. So I need to, once I've said what these things are, I need to know what du dx is. I need to differentiate my u. Joe, what will du dx be?
1.
Yep. And over on this side, I need to find out what v is by integrating my dv dx. Megan, what will my integral of cos 3x be? And you can use what we just had a minute ago.
Sine 3x over 3.
Yes, it is sine 3x over 3. That's right. Okay. Then, here's the Redbox rule. So to get my integration, it's just a case of substituting in. So I need to put down what u is and times it by v. Then I need to take away the integral of v times that by du dx and write my dx down. That's my substitution line. Were you happy with that at that point? Okay. Over here, we can keep these separate. If we want, we can just write them as one thing. X sine 3x over 3. Over here, on the right, what can just disappear altogether? The 1, it's having no impact, yeah. Then if you're integrating, and there's just a number, not a letter, just a number on the bottom, I would take that 3 through the integral sign. So that 3 is a dividing 3, it's like a 1/3 of the integral of sine 3x. Is everybody happy that that 3 has just come through here? But it's on the bottom of the fraction, so it's got to be on the bottom, so you can't just put a 3 at the front, it is a 1/3. Are we all happy with that? Okay, so this left bit here, I just keep writing this down over and over again. And minus 1/3 over here. And then I've got to do this integration. So, Rosalind. Are you a Rosalind or are you a Rosie or a Ros?
Ros or Rosie?
Ros. Okay, Ros, I probably remember. Ros, can you integrate sine 3x using maybe that bit of paper we made notes on the other day, a minute ago?
Minus cos 3x over 3.
Minus cos 3x over 3. Yeah, I'll put that in a bracket to show it's multiplied and it's not being taken away. What else should I write down at this stage? Yeah, because there's no more integration, and I'm just going to pause that recording there for a minute. So, continuing with this over here, I've got minus a third being times by this bracket, but again I just write this first bit down here. Now how can I write this bit down here more nicely? I've got minus a third times by minus cos 3x over 3. Can we write that down in a simpler, nicer way?
Plus.
Yeah, the minus make a plus.
Cos 3x over 9.
Yeah, the cos 3x, and on the bottom, 3 times 3, they're on the bottom, 9. And put your plus c in. There we go. That's an answer. Okay, that's absolutely fine as an answer. So I'm just going to put over here, that's a fine answer, because you may find when you do questions like this and then look in the answer book, or the answers in a textbook, it's done slightly differently. Is there anything you see that could be taken out as a factor? Anything that goes into that and goes into this? You're on the right lines, but a third doesn't fit into a ninth. A ninth, yes. A ninth fits into a ninth, and a ninth fits into a third. You might come across some books that say, I'm going to take a ninth out as a factor, and then in here, if I rewrite this, is that correct? No, okay. Well, actually, I'm going to scrub that over 3 bit altogether. What do I need to do to make this bit here correct? Because it should actually be a third of it, and at the moment I've got a ninth of it. How many ninths are the same as a third?
3.
Yeah, so they would put a 3 there, because 3 ninths is the same as a third. Then over here on the right, they just wouldn't put that 9 in, because they've already written it at the front. So you just get cos 3x. And your plus c at the end. So basically they may rewrite it like that if they don't want any fractions inside the bracket. They may just take it out. So there's only one fraction written down instead of 2 fractions written down. There is nothing wrong with the answer you've given here, but if you've got an answer you think is absolutely fine and you're convinced it's correct, and in the book it says something different, just see if they've done an extra step of taking out a common factor just because they want to. Okay? Probably also worth mentioning that if you see this in a different textbook, you could swap the D's and the U's and the V's around and have it written slightly differently as well, but this is the way it's in your formula book and it's in your textbook, so I will stick with that. Right, what's the first thing I've got to do then? What's the first thing I've got to do?
Choose.
Yeah, I've got to choose my bits. So, what are my 2 bits first of all?
X squared and e to the 2x.
Yeah, x squared and e to the 2x. So I've got to, first of all, choose what u will be, and I've got to choose what dv dx will be. Those are the 2 bits that are written on the left-hand side of my formula, of my rule. I want one of the bits that becomes easier when I differentiate it. Which of those becomes easier when you differentiate it? X squared. Okay. So if u is going to be x squared, the other bit has to go over here, as long as you can integrate it. Can you integrate e to the 2x? The answer is you should be able to if you did that chapter right at the end of year 12. So we'll come to that in a minute. Right, after we have written down what these are, next thing is I need to know what du dx will be. What will du dx be? This bit should be nice and straightforward. 2x. And over here, I need to know what v will be. Can you remember how to integrate and differentiate these things? 2e to the 2x is not quite right. That would be if you were differentiating it. So let's just have separate to that a minute. Okay, a quick recap. If we are integrating e to the mx, what do we get? This is like a recap of these rules. What do we get if we integrate e to the mx? And the other one I'll go through with you is if we are differentiating it, what do we get? We need to know these two as well.
1 over m.
This one over here, yeah?
1 over m, e to the mx.
Yeah, that's right. The e to the mx bit stays there. And as you're integrating, you divide by the m. And you can put your plus c. So that's the integrating one. What is it for the differentiating one?
mx.
Yeah, the m comes down the front and multiplies. It's still e to the mx. Okay, so that's just a recap. Okay, from there. So with that information, what will my v be up here?
X over 2.
Yep, thank you. E to the 2x over 2. Okay? So now, I wonder if I can be clever and freeze that up there, the title bit. No, not quite. Okay, now I'm pressing too many buttons and getting a mess. Right. Okay. So, next bit then is do the substitution. My integral becomes, using that Redbox rule right at the top of the board, u times by, well, you can do this bit yourself. Just now rewrite, you're using this bit over here and you're just substituting the bits in. I'll do it as well, but I won't talk it through. And if you agree with me on that line, see if you can just do anything to that line to make it a little bit nicer. Don't do the integration yet, but just look at it. Is there any way you can just write that more nicely? Right. Did we all get the first line here, just a substituting bit? All I've done here is there was a 2 on the top and a 2 on the bottom. They'll cancel each other out, so I'll get rid of it. And if I'm integrating this, it's normal to write the x before the e bit. Okay? So that's all I've done there really, is cancel the two 2's and I've written the x before the e to the 2x bit. It's just a normal way round that we do it. So, have we made any progress? Do you know the answer to this integral down here? Silence is what I'm expecting. You shouldn't know the answer to that integral down there. What do you think we do? What could you do? If I had just said, here's a question, how would you go about answering that question?
I do another
By doing another integration by parts now on that bit. Yes. If you look what's happened, we started off with this integral here with an x squared in it and the e to the 2x. We have now got something which doesn't have to be integrated and an integral, but there's no x squared there now, there's just an x. It has got better, it has got easier. But what I actually now need to do on this bit here, we need to treat this bit here now as a question on its own. Okay? So treat this bit as a new question. So when I'm doing these, because I've used I for my integration earlier, I now call that bit J. Just seems to make sense to me. So I've got a new question now. My question J is I am integrating that. Okay? And how do I do that? Well, I integrate by parts. Just what we've been doing. So, if I'm now working on this part of the question, Vanessa, are you known as a Vanessa or are you known as anything else? Vanessa, right, Vanessa. What will I do here? If I'm treating this as a brand new question, what will I do?
Use the U and the
Yep, okay. What will you choose them to be?
X as the U.
Because that immediately makes you have something easier when you differentiate it. So this bit has got to be,
And the 2x.
and we already had this scenario, we already know in this question what the integral of that is, we've done it already. What's the integral of that bit?
Use the 2x over 2.
Yep. Okay. So now our integral j will be, using the Redbox rule, it's u times by v minus the integral of v times by du dx. And I reckon we've just got time to finish this question. So, I'll write this bit down, just put it all over 2. What can disappear over here? The 1. Where could that 2 go? Outside. Keep writing this bit down here, don't have to do anything to it. Write the half down. Vanessa, I think I've asked you this already. What's the integral of e to the 2x? Yep. I have no more integrating to do. I will put my plus c down. Can anybody tell me how I could write that line down using less ink? It's not going to be anything to do with the first bit. What's this bit here? How can I write this bit down?
Open over 4.
Yeah, because that's a timesing. So that's minus e to the 2x over 4. And that is what j is. That's what that second bit is. So, if I bring back from earlier on, the integral I'm doing is that take away j, because that bit there is my called j, which is this bit here. So now put it together. I'm putting this line here together with this line here. My original integral, was equal to that x squared e to the 2x over 2 take away this thing here I worked on, which I called j. I do need to put it in brackets, and then j is this thing here. I'll stick the plus c on the end, that doesn't need to be in the brackets. Why did I just need to write it in brackets? What might I have forgotten to do otherwise, or what do I need to do now?
Minus it.
Yeah, that's right, the minus and the minus there will make that bit a plus. So I get x squared e to the 2x over 2 minus plus and that is a perfectly fine answer, but if you looked in an answers in the back of a textbook, it probably wouldn't be written down like that, even though that is a perfectly fine answer. What could they take out as a factor? A quarter. What else is in each bit?
E.
Yes. Okay, take that out as a factor. Okay, what do I times this by to get this first term here? In other words, what's missing here compared with here?
2x squared?
Well, certainly an x squared.
No.
Okay. Now I want a half, so I need to put a 2 there, because 2 quarters, 2 over 4 is the same as a half. So that's that bit dealt with. That minus sign goes in. What do I need to do to get this bit here?
2x?
Yes. Because I need to introduce an x, and 2 over 4 is the same as a half, which is what I've got there. Then I come to my plus sign. What do I need to write down to get this bit? 1. It's exactly the same as that. Yeah, 1 plus c. Okay, so that is that example finished.